Okay, now we're going to look at the negative exponents in chapter 6, section 6.1. We already went over this briefly in the last video. So we have applying the rules. Again, you need to subtract the exponents when you have a quotient. So if we have a higher number in the denominator, then we're going to end up with a negative exponent. That gives us this rule here. So we have rule 1 is a to the n equals 1 over a to the n. So if you have a negative in the exponent, it comes underneath. Be careful that unless you have a negative out here, you're not going to have a negative value for a coefficient. It's just bringing that a to the n, it comes down to be positive exponent, but the sign of the coefficient does not change. So here, if we have the opposite thing, 1 over a to the negative n, that will come up and go in the numerator, and the power of the exponent changes, but not the power of the coefficient, which in this case is just 1. Rule 3, we can actually flip around. So if we have a to the negative n, or a over b to the negative n, that is really the same as saying a to the negative n over b to the negative n. I could actually split those up to be a to the negative n over 1 times 1 over b to the negative n. It's kind of a long way around just to show you. And then a to the negative n, I could use this property over here, right? And that would tell me that equals 1 over a to the n. Just switch the power around. 1 over b to the negative n, that would come up. Change the power of the exponent, or the sign of the exponent. Sorry, not the power, but change the sign of the power over 1. And we get b to the n over a to the n, and then b over a to the n is finally what we end up with there. Make sure that looks like an A, not a 9. So it's just combining all the rules into one thing so that it's much easier to deal with. So basically you're just inverting, you're doing the reciprocal and then changing the power of the exponent. So that's a really great property and one to memorize. So what I notice with my Math 140 students right now, which will be that course numbering is changing to Math 99. So that'll be your next course most likely. If you're placed in this class correctly, you would have be in the STEM track. So you are going to really dive in more in that class, and I noticed that some of them don't have the solid foundation with negative exponents. That's what they said they wanted. They wish they had a little more coming in. So we're going to have plenty of practice with those. So now let's go to page 73 of your workbook. So here's a little warning here for you in your notes. It is important to note a negative exponent does not imply the expression is negative. So that's what I was talking about before, like the coefficient. Only the reciprocal of the base. Hence, negative exponents imply reciprocals. Also recall the rules of simplifying. All exponents are positive. Each base only occurs once. There are no parentheses. There are no powers written to powers. Now, no parentheses meaning like we shouldn't have any product to power rule left. But when you're doing your electronic homework, keep in mind that you're going to need to put parentheses around a numerator or denominator possibly, because otherwise the syntax won't come out right. It'll mark it funny. So the best thing to do with that is actually use the little palette, the equation editor tools that they provide in there. So do watch that and check your syntax, but that's not the same as what we're talking about here, removing parentheses. You're just going to be having to enter it in, like if you were doing a calculator or something, to group the numerator and group the denominator so it doesn't come out incorrectly read by the computer. So let me know if you have trouble with that. I can probably do a little tutorial on how to enter those as well. So for example 6.12, we have A here. We're going to apply negative exponents rules to simplify the following expressions. So you could try some along the way too. You can pause and see how you do with it on your own, and I'll point out which property we're using. So first thing, if you can simplify anything inside the parentheses, that's always a good idea. So here I have m to the first over m to the fourth. So I usually just kind of write myself like a little line here. And I'm not going to deal with this yet, that exponent yet. But I have m to the first over m to the fourth would give me m to the -3 or 1 over m cubed. Okay, you can kind of think m goes into m once, m goes into m to the fourth, and leaves me with m cubed. You can kind of think of it that way too. Then we have n to the fifth over n cubed, and that's going to give me n squared. So that's going to be up here. So I have 1 times n squared. I can just really get rid of that 1. Another way to think of this too, which works nicely, when you have this here and you're subtracting those exponents, you get 3. You get, if you're just doing 1 minus 4, you get -3, but think of where the bigger one started is in the denominator, so that's where it needs to stay. So it's the absolute value is the power. Now I'm going to apply the rule. I'll write it down over here. This one here, ab to the -1 is b over a to the, or actually I should say -n to the positive n. So I'm gonna just flip this around. So I have m cubed over n squared. Now I need to apply my power or product or quotient to power rule, which one we're working with. This happens to be a quotient. So I would multiply my exponent. So I have m to the 6th over n to the 4th. And then I'm finally done with that one. Okay, so now I think I got the box I like. Now for part B, we have 7x to the -5, all divided by 3 to the -1, y, z to the -4. So again, I'm just going to put a line down here and get myself situated for setting up where my things are going to go. So 7 isn't to any negatives, so I'm just going to leave that there. So I'm going to raise to a power just 1, raise to the power 1. So x to the -5 will come down under here as x to the +5. My 3 to the -1 gets pulled up here, so I have that. Oops. I don't need to write the power of 1 on that. Then the y just stays. The z to the -4 has to come up. Whoops, and hope you notice that. Just make sure the sign changes. When you change its position from, bottom to top or vice versa, you have to change the power. Then I'm just going to calculate that out. Change the sign of the power more specifically. So we have 21 z to the 4th over x to the 5th y. And that is the answer for that one. So pause the video for part C and you can try that one. See if you can do that as a classwork. Okay, so you should have gotten 2/5 a to the 4th. It's just we're taking this a value, bringing it up. Okay, changing the sign of that exponent. So it's changing the color of my little boxes too, so they're not so distracting. The colors are more blended. So we have properties of exponents here. This you really want to memorize, okay? So write this whole thing here down on an index card and have it handy while you're doing your homework and things like that. You want to make sure you're accurate with them, and then you'll eventually need to memorize these. We're going to be proctoring the Math 99 and Math 141 from here on in. This term was an anomaly with no proctoring required for most people, but even if we have to do it virtually, that's what we've been told we need to do for those other classes. So just keep that in mind, that you want to make sure you memorize things, because a lot of times the professors in the higher up classes are not going to allow note cards or anything, sometimes not even calculators. So I want you to be prepared as if you were in that situation already. Actually, writing these out every time you do a set of problems is really helpful too for memorization. Okay, so we're going to just write to memorize these. All right, so now we're going to move on. We just have a couple more problems. They're kind of doozies, like big ones. In your e-homework, I build it up, so some of them will go very quickly, some will take longer. I tried to avoid really huge ones, kind of like these, but anyway, I'll give you a few on paper too, but I think this is something that's just very skill-based for you to do. So here we have example 6.13, page 74 of your workbook. 4x to the fifth y squared z, all raised to the second power, times quantity 2x 4y to the negative 2z cubed, all raised to the fourth power. Now, I want you to be careful of something, like we're not going to distribute here. We don't distribute over multiplication. We also don't like technically call it distributing exponents. We call it applying the product to power rule. So that one is where we would have a b to the n equals a to the n b to the n. Okay, if I could simplify anything within the parentheses first, though, like if I had a like base in there, I would do that, but I don't have that situation. So I'm going to have to simplify this first, apply the power rule, and then apply it here, and then simplify after that. So we would have 4 squared. Don't forget about your coefficients. And if this were negative, I would have to put it in parentheses if my coefficient were negative, because it started in parentheses. So keep that in mind. It's really like 4 squared. And then we have x to the fifth squared, which I'm not going to write everything. What I'm doing here is x to the fifth squared, but then I'm going to multiply the exponents, and I think at this point you probably have that down. So I'm just going to go ahead and write it out. So I would write it as x to the 5 times 2 is 10. Y squared squared is going to be y to the fourth, and z to the first squared is z squared. Okay, so that is my first one there. I'm going to kind of run into that guy. Let me fix this. Okay, so I made a little more room there. So now I have 2 to the fourth. I have x to the fourth, so that's going to be x to the 16th. Y to the negative 2 to the fourth is going to be y to the negative 8. And then z cubed to the 4th is z to the 12th. Okay, so now we're going to go crossways and simplify. So I could force this to have a like base of 2 because 4 would be 2 squared. So 2 squared is going to be 2 to the 4th. So I can rewrite that right here as 2 to the 4th. We do that a lot as you go on in math. We kind of manipulate. If we can get a like base, that's really nice because now I can go 2 to the 4th times 2 to the 4th. Now I'm adding exponents, don't forget. So get out of multiply mode. When I'm multiplying exponentials, I add the exponents. So x to the 10th times x to the 16th. Keep the base, add the exponents. Remember, only when it's raised to a power is when I multiply exponents. Then I have y to the 4th times y to the negative 8. So that's going to be 4 plus negative 8. So be careful of that. Don't kind of do a double negative there because it's not underneath. So 4 minus 8 is going to be y to the negative 4. Just leave it that way for now. Then I have my z, and I have it squared and then a 12. So add the exponents. I get 14. Now my last step is going to be, I could calculate this out, 2 to the 8th to be 256. Now, if you weren't comfortable with what I did here, with this manipulation, you could just calculate it out. Just do 4 squared times 2 to the 4th, and you'll get 256. So no worries there. You don't have to do that. It's just something I'd like you to know exists. X to the 26th. My y to the 4th comes down here, and my z stays there to the 14th. And that is my answer. I'm just going to center this y to the 4th just to make it look a little better. Okay, so there's your full answer for that one. For B, it's a little trickier. You can do it a couple of different ways. You can simplify before, or if possible, or you can actually just go ahead and raise each of these to the negative 3, which might be helpful in this case. I feel like it might be just a little more streamlined to do it that way, because you're going to get rid of some of your negatives that way. So let's try that approach first, but you could attack it a different way. I could do the alternate also if you want. Here we have, so I'm going to first do the product to power. So kind of different. Here we have a product to power for the numerator and the denominator. So I have 5 to the negative 3. X to the negative 8 times negative 3 would be, or raised to the negative 3 is going to be negative 8 times negative 3 is 24. And then y to the negative 7 raised to the negative 3 is going to be y to the positive 21. Then I have 15 to the negative 3. Then I have x to the negative 30, y to the positive 30. Now I can start switching things around, or I can just kind of subtract exponents. On these, I cannot get a, right here, the coefficient. Just take one piece at a time. 5 to the negative 3 over 15 to the negative 3. I'm just going to swap them. So I'm going to have 15 cubed up there and 5 cubed here. Again, we're using A over B. Let's look up at the top of the page to the negative n. Same as A to the negative n over B to the negative n, really is what I'm doing. And then that would be B to the n over A to the n. So I just can switch those. This piece here the x's. What I'm going to do is I'm going to pull this up just so you see what I'm doing. I'm going to do x to the 24th divided by x to the negative 30. I subtract exponents, so I'm going to go minus negative 30 there. Okay, so I have a double negative. So what happens is I have 24 plus 30. So that's going to give me a positive 54. So I'm going to write that up in the top. Another way you could think of it is you could bring that x to the negative 30 up above, so it would be x to the 24th times x to the 30th, and I would add exponents. Now the y's, I'm going to end up having y to the 21st minus 30, because I subtract exponents when I'm dividing. So that's going to give me a negative 9 there. So in that case, it has to stay down here. Again, you could just find the difference in the exponents, and where the one with the larger exponent is where that will stay. Okay, so there's one more thing I can do for simplification here. I can take my numbers and I can actually write this as, I'll do it over here, 15 over 5 cubed. And then I can simplify that to be 3 cubed, because I can divide 15 by 5. And then I get 27. So I can write this as 27x to the 54th over y to the 9th. Okay, now you can try and do this last one on your own. It is the last one of this set. So you can do that for classwork. You could also try doing this alternate method by simplifying inside parentheses first. I'll actually do that underneath following the video. I don't want to do it right now because we just kind of tackled that, but I'm going to show some alternate methods afterward. Okay, so I started C off in case you're stuck with your classwork. So what I did was just apply the product to power rule for all of these. I really can't simplify ahead of time like I could for this one because they're not all inside the same parentheses raised to the same power. So that's something really to be cautious of. That's kind of why I did it this way to begin with, because I think that's probably less chance of error. So now that I've done that, I'm going to go ahead and simplify the numerator. So I have 2 to the 4th. I have x to the 8th times x to the negative 8. So that would be 8 plus negative 8. Remember, whenever I have multiplication of exponentials, I'm adding the exponents. So it's 8 plus a negative 8. So that's going to be x to the 0. And we talked about that, how that equals 1, correct? That was a ways back, but remember, any value, any base to 0 equals 1. So just track that right there for now. Then I have y to the 12th times y to the 12th is going to be y to the 24th, because remember, I'm adding exponents. Now underneath, I'm just going to look here that x to the negative 12, that can come up to the numerator. And the y to the 8th, I want to simplify with this here. So if I have y to the 24th minus 8 in this case, because it's a quotient, so I'm going to have y to the 16th on that one. Okay, so now I'm gonna just push this up. And so sometimes just separate it out like by columns like that and do your work. So we have 2 to the 4th, and I can just write that out as 16. Then I have my x to the 0 is 1. So my x to the 12th. So this isn't raised to the 1. It's actually the number 1. Right? So we just kind of get rid of that as 1. And then I'm going to leave this as x to the 12th. And then I have y to the 16th. We just like alphabetical order. And that is it. All the steps for that one. So now I'm going to do the alternate method for B. I'm just going to rewrite the problem. You don't need to do this one this way. If you don't want to get confused by that, then just go ahead and skip this part. But I thought that people might be interested, and I have to be careful how I write this because the parentheses go all the way around, and that's the thing that allows us to simplify within them first. Otherwise, we wouldn't be able to do this method. So now I'm going to push this up. So I have, I'm going to simplify in the middle first. So I could do 5 over 15 is 1/3. I can also simplify this here to be x to the -8 minus 10, because remember it's subtracting, so it would be x to the -18 there. So I'm going to start tracking this here. So 1 over 3. X to the -18 would make it be down here. Oops, except I got to change the sign. Okay. So then I'm going to do the y's. -7 minus 10, which is really like plus, right? So that's going to be y cubed, and that's going to be up top. But then remember, fix this line, it's all raised to the -3. So I still have to apply that, sorry about that, the product to power rule and deal with that. So there's a couple of different ways I could do that. I could take this whole thing, I could go and flip it. I could do 3x over 18 y cubed to the +3. So that's keeping me positive. Then I could do 3 cubed over x to the 18 times 3 is going to be my 54. And then y cubed is going to be y to the 9th. So you can see here, once I calculate out that 3 cubed to be 27, x to the 54th over y 9th, I get the same answer as I did before. I don't know if that's less steps or not. It's just a different approach. And conceptually, I feel like it's a little bit trickier. So it might not be the best for when you're first doing it, but you might enjoy just having a change of pace as long as you're consistently correct. There's, kind of multiple paths to get to these things. I try to do systematic at first when you're first learning it. And I would suggest that for you to kind of get in a pattern. And then you could say, oh, well, actually, I could apply this concept here. This rule applies here too. So you kind of get the gist and get more comfortable with it. All right, so that's it for this lesson, and have a great day.